do a higher duty cycle and add safety features like automatic shut off if the power is held down at these high, like um, close to 100% duty cycles. I can do an automatic like shut off if the power is held down too long, so it doesn't overheat the heating element. But for now, we're gonna do this with 12 gauge wire. So I'm gonna activate the heat. It's already melting the solder at the tip. And it's doing the surface melting, which is increasing the thermal conductivity. Some of the flux kind of melted out. And once the thermal conductivity increases, then the whole wire is starting to get hot. And once the temperature of the entire wire gets high enough, then it will start to wick. The solder will start to flow and wick into the cable bundle. And so we're getting to that point where it's starting to wick. Yeah, it's starting to wick right now. I can see it flowing in. I'm just going to keep adding solder. And again, this is lead-free solder. I'm going to add a little bit more flux. There we go. And if I, touch these alligator clips, I can feel that they're getting really, really warm. And that means that the heat is pretty substantial coming out of it. Like most of it's a 10 watt, right? I mean, you think this would be like, oh, you need a 60 watt, soldering iron to do this kind of thing. Which is true if you're doing temperature control, but this is not temperature control. Temperature controlled soldering iron requires a large thermal mass, and this doesn't have a large thermal mass. And so most of the energy is going to the working area of the solder joint. So you can do a lot with 10 watts. I mean, and it kind of goes to show, like, tells you like how much of that 60 watt soldering iron is actually used to heat up the solder joint. And I have a feeling it's very inefficient. I have a feeling it's more like maybe 20% of the actual heat is going to, just cleaning the tip a little bit, is going to the actual solder joint. And that'd be an interesting experiment to just like actually measure that. I'm not sure how you do that. You probably have to get a custom block of metal or something, and like measure that thermal mass and heat capacity and try to calculate like the number of seconds required to heat it up, and like how much energy does it take versus how much energy is inputting into the system. I'm just going to keep globbing it on, see how much I can glob on before it's like starts to get ridiculous. Why not, right? Yeah, it just keeps globbing on, and it's, from what I can tell, wicked all the way through. All right. Clean it with the Q-tip. Okay, these alligator clips are really hot. I'm just going to put a little bit more solder on the side here. Just a little hard to solder while like getting a good angle at the camera as well, because they're not usually like, it's hard to do both at the same time. Like what's good for soldering angle for me is actually not necessarily the best angle to show on camera, especially when I don't have one of those like cool cameras that can like that have a microscope built in. Cool. More flex will help. I don't know. I'm just going a little crazy right now. It's probably the biggest blob of solder I've ever done with this thing. Yeah. Might as well put more. Okay, that alligator clip is really hot. I just touched it and it's like, ouch. Oh man, this is like the biggest blob that's totally like gnarly. I probably put too much. But whatever, it's a good test, I guess, huh? Okay, that's ridiculous. And we can adjust the power to actually add more power to it on the final design. Still pretty warm. Okay, that's like too much solder. I would imagine this is probably what soldering 10 gauge wire is, like just like putting this much solder on it. But yeah, it's pretty gnarly. And like I said, this is lead free, so leaded solder is going to work even better. If you can do this with lead free, leaded is like no problem. Even in the original Kickstarter for the original Solderdoodle, doing lead free is actually only, even with 24, 26 gauge wire, is only with a fully charged Solderdoodle. Because after a certain time, after about 30 minutes, the voltage gets below like 3 volts. And then it starts to get into a very low wattage state, which you can still solder leaded solder with for using the Solderdoodle for the entire time. But for leaded, it takes a little bit more power. So it's only like reasonable to solder lead-free solder with the original Solderdoodle while it's fully charged. Like, and it only and so for about like half an hour, and then it'll like start to, the voltage will decrease too much. Solderdoodle Plus can solder lead-free solder the entire discharge of the battery, all the way up until when the battery cuts out. And that's because there's 2 cells in series, and it's a higher voltage stepping down to 5 volts. And so it's constant 5 volts, constant 2 amps for the entire discharge cycle of the battery. So that's how you're able to get these kinds of like amazing results. Since I launched Solderdoodle back in 2014, I haven't seen anybody else create a USB rechargeable soldering iron. I have a feeling it's because in order to do it, you actually have to use a lot of the higher quality materials, especially to do charge and discharge at the same time, and having that reliable capacity and reliable performance throughout the entire discharge cycle of the battery. And like I said, I was confusing. It was when I was first trying to get companies to manufacture the Solderdoodle, it was confusing because when I told them what batteries I was using, which was the Panasonic NCR 18650B batteries, they were unwilling to use those battery packs because they said that these were too expensive. And when they quoted me, they were, and I was like, well, but you know, they're not set up. They don't have stock of the high quality batteries. They just didn't. And I was like, well, get some stock. And they're like, okay, we'll get stock, but that's going to cost you like $16 a cell. I was like, okay, that's kind of ridiculous. So you have a chicken and the egg thing. You have batteries that are on the market that you can buy that are high quality and can last, but then you have the vendors and you have the factories that are being told to use cheaper cells, and so they don't stock it. And then so like when I request high quality cells, then it becomes more expensive for me to actually try and improve the quality of what's on the market. I don't want to reduce the quality. I want to keep the quality high. Yeah, it's amazing just through this whole discovery of design, what you can figure out and how you can figure out how the market works by dipping your toes into the design process and trying to design products. But now I found out that I have a feeling with these new clips that even if these batteries are more expensive, they're going to be less reluctant to push back against me because I have designed this battery pack so easy to manufacture and so easy to install the batteries that they literally just have to get a box of these and then just pop them in like this, and that's it. And so if they push back against me and say, oh, these cells are too expensive, I'll say, hey, look, you know, I got a box of these coming your way. Just get them and pop them in. And you don't have to have stock. I'll give you the stock. I'll just have the company ship it to your address. How about that? And that way they don't have to solder, spot weld any tabs. They don't have to crimp any connectors. They don't have to do anything. Now, you know, looking back on it, 4 years ago, if I had these clips, would I be a lot further along? Yeah, I think so. But it's just one of these things, like, once you go into production, you really can't appreciate all these details, and there's not a lot of people working on these small electronics. Because most people they just go online, they just buy whatever battery packs available online, or for $5-10, and they say, "Oh, I'm happy," and they never actually bothered to design their own battery pack, which is, it's reasonable. It takes a lot of time and money to do that, but then the market becomes stagnant and filled with a lot of batteries that don't last. So, so what I'm trying to also prove is that this technology is available. It's not that hard to produce, and it's all open source. It's on Instructables.com how to build it, and just to prove that you can build a pack that is high quality, and once all the vendors and manufacturers are lined up, I'm still getting quotes for the final production assembly. They're the same company that makes the heating element, so the same company that makes the tips, and the same company that made the switch and the internal spring parts. They're quoting me for the entire assembly as we speak for Solderdoodle Plus. And this time around, I'm going to make sure that it's going to be very difficult for them to find a reason that they won't be able to stock these parts and manufacture it when it's so easy to assemble. It's literally like 2 circuit boards, 2 batteries, and 2 cables. One of the cables is actually, this heating element cable, and then also the cable that interfaces between these 2 circuit boards, like this. And so there's no special, you don't need a lot of equipment to manufacture. You just need screws, 4 screws. The touch controller is off the shelf. All the parts list is on Instructables. And well, actually, I'll show you. I'll plug this in and just show you the 2 charge indicators per cell. So right here, might be a little hard to see, but I'm going to get this USB cable, and I'm just going to charge it, and it's still on. I'm going to charge it, and then maybe you can see. Maybe the camera will pick up these 2 little lights that are going to turn on, showing that it's charging each individual cell. Oh yeah, it kind of shows up. So these 2 lights are the charge lights for each of the charge controller chips that are on this board. Yeah, so the 2 LEDs are on the back of this board right there, and those are connected to the charge controller chips. One right here, and the other one right up there. And you can charge and discharge at the same time. Yeah, so I can show that right now. I'm going to activate this at full power. So it's active, and then you can see it's still charging. So you can use this as a corded device if you wanted to. Like, let's say for whatever reason the power is out, like all the cells are dead, and you didn't want to wait for it to charge. It takes about 3-4 hours to charge up from completely zero power. But you can plug it. You can plug it in and then use it while it's charging. Actually, another issue I found with the original Solderdoodle is with these packs, the connector, these are all hand crimped by me. So this is my factory where I build Solderdoodles, is like in my apartment. Sometimes going through quality control, I would actually do a pull test on this connector, like, you know, just pull it, because make sure sometimes the crimping action actually crimps a little too strongly, or like catches it the wrong way, and then like this connector might, you know, disconnect. Then I'll have to crimp it again. So if there's any existing customers out there that have that problem, I can remedy that for you. And the symptoms might be that you can only use it while being plugged in. But because Solderdoodle Plus just has these clip-in battery connectors like that, there's no issue like that. Like, you don't have to worry about the spring like coming loose or anything. It's just right from the circuit board assembly. You can drop in the battery and that's it. So yeah, so when these are fully charged, just like the original Solderdoodle, when the batteries are fully charged, this green light will turn off. And you can notice, I mean, you might have to stare at it for a while, but it is truly charging each lithium-ion cell individually, because you can see, like, once one cell is charged, one light will go off and the other may or may not. Like, one might still actually be charging while the other is fully charged and is not charging anymore. So these are completely independent cells that are being charged because they're on, like I said, isolated grounds. Here's the transformers that are isolating the grounds of each charge controller. So here's the driver chip. There's one driver chip right here for one transformer, and the other driver chip for the other transformers right there. Let's see. Right there. And so it's actually doing a, you know, it's doing like a sine wave kind of action through the transformers, and then on the other side of the transformer, we have an isolated ground to each cell, to each charge controller. The way I learned that is I actually took here's the original Solderdoodle control charge controller boards. I try to tie two of them together. That's not a good idea. It actually creates a short. So what I ended up doing is plugging, you know, one charge controller to one like USB cord, and then charging another, charging another charge controller like this, right? And then what I did is, so these are two different cells going through basically a wall board, you know, a USB to wall socket adapter. Each cable is on a different wall socket adapter. And then what I did is I tied the positive of one end of the output to the negative of the other end of the input of the ground. So positive of one end is going to the ground of the other circuit board, and so that's connecting the outputs in series, and so the positive negative of this entire like series connected circuit became the batteries connected in series, but each charge controller on individual isolated grounds. The isolated ground is the actual USB wall socket adapter on each wall, because each wall socket adapter turns 120 volts AC into 5 volts DC, so it's going through a transformer, and that's how I was like, oh wow, that's how you do isolated grounds. And so I was like, there's got to be a way to shrink that assembly down into one circuit, and that'll fit into like a Solderdoodle plastic case. And let's see, that's how I figured out how to charge, cells in series with a charge controller on each cell. And so I'll show you what it shrank down to. So you have, two circuit boards, 2 wall adapters, right? And then, because each of these wall adapters is basically a transformer, and I shrunk it down into this. So here's one transformer, one halo transformer. Here's another second halo transformer, and then we have the 2 charge controller circuits up here. So this whole thing got shrunk down to this, and these are the 2 cells, right? And that's not including the spaghetti monster prototype. Actually, if I bring let me demonstrate what the whole prototype looked like before. So if you combine this charge control scheme with, this original Solderdoodle spaghetti monster mess, actually this is what the first Solderdoodle looked like. So, pretty messy. So that's how I generated the first schematic, and then got a prototype. Down to this and this. And it's all open source. And just trying to push the limits of technology. What can we do with lithium-ion batteries that may surprise you? I'm a believer in lithium-ion technology, and I don't think we've pushed it to the limit. I think the thing holding us back are companies that just cut costs for the sake of cutting costs, and it's really hurting the market. It's really giving us poor quality. It's preventing us from enjoying the technology that is available to us right now. Honestly, and just calling out this kind of reduction in quality for no other purpose than to make some profits increase for some people. And the rest of us are left with consumer electronics that catch on fire, that break in a few months, and they're not going to stop. And this kind of showing that, hey, the quality's so bad that even someone like me can design something that lasts longer. The standards are pretty low these days when it comes. Now, software is a different issue. The software out there is pretty amazing. You can do a lot of stuff with your smartphone these days, but I'm talking about the actual power source. We were talking about what powers everything, what gives you the ability to make your device turn on in the first place. That's really not the priority of a lot of these companies. And I'm hoping that projects like this can actually change that for some reason. It's a shot in the dark. I might be talking into the fog, but I'm just letting people know it is possible. And just with a little bit of experimentation, you might be surprised at what you find out there, and how much you're able to do on your own. I'm a big believer in people making their own products. I think it's totally doable. People shouldn't be if you wait for other companies to kind of come around if I had to wait for someone else to make a product like this, I'd be waiting a long time. It may not ever happen. And you know, I just can't wait, and it just kind of bothers me that there's companies not really pushing ahead with the technology these days, especially when it comes to just power management and just batteries in general. Lithium-ion technology is not disposable technology. It's not a disposable battery. They shouldn't have to be thrown away every 6 months to 12 months. Lithium-ion batteries should last 5 to 10 years. And they may reduce the capacity, may not get as big a charge, but it should still last. Like, for example, even after 500 cycles, and this is, the capacity goes down to 1,800 milliamp hours. Okay, well, instead of, a little over 1 hour, you're going to get, 10% of that. So that's going to be like, instead of like a full hour, it's going to be like 50 minutes. Well, 50 minutes is, if that's considered the end of life of a battery, where it goes from an hour to 50 minutes, that battery is still freaking good. So the end of life for a company's specification for a battery should still be usable for another like 5 years. If a battery just dies, and if a battery dies, you never know. Maybe it's the actual circuit. Maybe the circuit fried, and the battery's still good. Maybe they didn't spec the current limit that well, or maybe the current limit creates overheating of the circuit board. Maybe they're using 1 ounce copper instead of 2 ounce copper. 1 ounce copper heats up more. 2 ounce copper heats up less. Are they using capacitors and resistors that are the right tolerance? Maybe 1% tolerance resistors and capacitors are 1 cent more expensive than the 5% tolerance resistors and capacitors. But if they cut costs, like to save a penny or half a penny, times a million circuit boards, that saves them a lot of money. But every so often, you're going to get a circuit board that's out of tolerance, and they overheat. So maybe the batteries are fine. Maybe the circuits are bad. How do you know? And that's the trick. Like, you don't. And they're saying, we have, you can't, take apart and repair your own products. Well, how do we know that you're making your best effort at the quality? Like, if we don't know this, then I should have the right to modify and repair my own products to fix the work that I paid good money for you to create. So and this pack can be used for other things. This could be used for really high quality tablet chargers, for example. Like, all you would need to do is just pop a different connector and just pop in a 5-volt regulator on this thing that outputs up to 2 amps, and just 3D print your own case, and then you got yourself a tablet USB cell pack that lasts for a lifetime. And then who knows, maybe future developments could have, instead of 2 cells, 4 cells. So now you have 2 in series, 2 in parallel, all with isolated grounds. This technology could be used for all sorts of things. Let's see. Let's see, what time is it? Well, it's 1:05. I haven't eaten lunch, but I'll do one more thing. I'm just going to poke some holes through some plastic just for fun. Why not? So I'm going to just use the needle tip and just kind of blast away, poking holes for fun. Why not? see how fast it'll actually, go through this thing. All right, there it goes. Boom. I'm just gonna Swiss cheese this thing. Maybe see how fast I can go. Oh yeah. That's ABS, so it doesn't smell that great, but all right, well, there we go. Swiss cheese. Let's see. Here's the spade tip. These are the new tips. We have the spade, and then we have the wood burning tip. And if you're actually an existing Solderdoodle owner, these tips are available by themselves in a pack with the other tips that came with the original Solderdoodle, the 3D print finishing tool. So the new tips are the spade tip, which is shaped like a spade. And then the other is this sharp fine point. I actually call this a wood burning tip because I found that it actually is perfect for wood burning. It's got a nice point for the heat to just focus on to give a nice fine wood burning abilities. I can do that right now. Just like I did notice I had to go to a little bit of a lower power because it would overheat, but all the final specifications for the tips. Actually, let me use this other tip. Here's a sharp tip that's already been kind of used. The one I have on is a little bit shiny. I think I'm using that. I don't have many of these new tips, so I'm trying to keep the shiny ones for, photography and like product photo kind of stuff. So I'm just gonna start doing some wood burning. Let's try to do it towards the camera. So what I found is you kind of poke at it, like kind of do little dots. And I found that sometimes is the best way to like move this around. Like you kind of like poking in at the same time you're trying to move. I'm trying to write upside down right now. So I'm just barely kind of like tapping, lifting, tapping, lifting, tapping, lifting. I notice if I try to drag a whole like line, it may get like stuck. Just going against the grain with some of these, trying to do curves is a little challenging, but it's not that bad. Let me turn it a little bit lower. I think it's kind of overheating that tip a little bit. Yeah, so I'm at the halfway, like half power right now. And this can be adjusted. This is also a prototype tip. I think um, I might have originally tested this out with different materials and different heating element resistances. Um, I haven't actually. I purchased this tip as an experiment like a while ago, and I'm not. I have a feeling I have to go through a couple more tests just to finalize the what the material and resistance final design of this tip should be. And the vendor can make any tip I want with any resistance that heating element that I want. So I just need to finalize that and give that as a specification. All right. So there we go. That's the wood burning tip. And that's just a prototype. Okay, and now I'll do the spade tip. I'll go max power with this one and just open up all that Swiss cheese. I'm just gonna like open the holes a little bit more. This does want to rotate a little bit. But if I wait for it to heat up, it doesn't really rotate. So I can make bigger holes. Oop. Yeah, I'll show that one. There we go, bigger holes. And the holes I started with the needle tip, and I can open them up. I can also do like chamfers, like make a countersink. Maybe like, for example, a flathead or flathead screw. You can do like a countersink for a flathead screw. Oh yeah, that ABS. Not the most pleasant smelling thing, but gotta test it out. And now the scooper. Yeah, so cutting holes in plastic and stuff like that. This is the test if you want to just do some fine finish work. So you want to turn the power down like almost all the way down for some fine finish work like this. If you just want to get rid of spider webs, like type of 3D print spider webby stuff, you just want a little bit of heat on the ends, and so you can just like knock off these like hair kind of 3D print hair issues, like hair residue that is just kind of left behind. I kind of scraped this one off, but I don't know. Let's see if I can get in here. So if you're doing overhangs, here's a good overhang in here. You may want to just kind of Let's see if I can get, this one's hard to see. There we go. You want to get in here. Here's like an overhang is, if this was 3D printed like this, gravity is going to like make these overhangs kind of fall down and they kind of stick out. So then you can go in here like this and just kind of at a low power. So you're not, with the scooper tip, you're not like, you know, melting the entire thing. You're not cutting all the way through it. You're just kind of melting the surface, and then you can get a nice flat like finish. So there's another overhang. So it's kind of like a little mound, just because it just falls with, while it's 3D printing an overhang, it kind of falls. And then you can just come in with this scooper tip, just kind of flatten it out. So let's see if you can see that. Now with a little bit more work, you can get this really flat. Just clean it up. So that's like before and after kind of show and tell. You know, I'm not going to do the conical tip because it's just like the chisel tip, except it's conical, and I actually got a lot of backlash on that. So I think conical tip is just an option for those who like conical tips. I personally like the conical tips, but you know, chisel tips, if you're doing like, prefer that, then you'll get the same performance, depending on what you like. So yeah, unless anybody else has questions, that if you want to put questions in the chat, I can answer them. Or if there's any ideas on anything else that I can turn off this fan for now. If there's anything else that anybody wants to see right now, you can also put that in the chat. Otherwise, I think I covered everything. And today's the last day for the Solderdoodle Plus Kickstarter project campaign. So we're almost funded. I think still a little short. But hopefully this video will answer a lot of questions and just kind of like show the performance and the quality, and just to show that it indeed is double the power of the original Solderdoodle project. This is the prototype of the original Solderdoodle. This is the Solderdoodle Plus with twice the power, and just showing that how much power it's able to deliver. It can do thicker wire. I showed doing the 12 gauge wire. I have a feeling it can go up to 10 gauge. We can adjust this power microcontroller to different duty cycles and add safety features to auto shut off if there's any overheating. I have a feeling this will be great also for car audio installers. They're doing thick wires, maybe speaker wire, and they just want to, you know, hit this button, full blast, get it soldered in like 5 seconds, and then like move on to the next joint. And we can add that feature. The idea is like this max power can be like pro level power, or pro mode, and it'll do like full blast, you know, quick pulses, where you can, it's almost acting like a momentary switch at full blast, 100%. And then maybe if you hold it down too long, we can add safety features that shut it and cool it down if it becomes too hot. And then we can basically have this tool cover all of the bases, whether it's like, you know, like a car audio installer all the way down to like doing hobbyists doing wood burning, and then and little circuit boards like Arduino projects, and we can cover the whole range of uses for this type of tool. And so not just soldering, but cutting plastic, 3D print finishing, getting into spaces where it's really tough, and also there's no cord, so you're not connected to the wall socket, so you don't have to bring an extension cord. You just go out there and totally replace the wall socket. Like, have this tool replace any corded device. Now, obviously, if you're doing, I've seen some YouTube videos where there's some old radio equipment that these guys are have like old radios, and their soldering irons like just giant fat soldering irons, because they have to solder these like giant like vacuum tube transistors, like and giant wires together. Like, you know, that's going to be a little challenging. But everything else besides that, this Solderdoodle Plus should be able to cover. And I think I've demonstrated. I've been on since 10:30 a.m. and let's see, it's 1:22, and I think I've covered most of everything, unless there's something, like I said in the chat, that someone wants to look at specifically, or have any ideas or questions. I think that is pretty much it for this demonstration. And if you're still around, and it is Christmas Eve, and I know it's like kind of last minute. Like I said, I probably should have done this a long time ago. I didn't even think about this idea until like yesterday. And I was like, huh, it's really difficult to like set up an appointment and then like show people in person, like, hey, can I come over and like demonstrate this to you? Because I thought that would be the best way, is, hey, you know, how about you try it out, and you have a project that you want to do? Well, here you go. This will maybe use this at your whatever project you want to do. But you know, it didn't turn out that way, and I have a feeling like doing a streaming demo or something, online demo, is actually better, because then it's really difficult to set up people's busy lives and stuff, and then I can basically just demo it and then show, oh yeah, this is exactly what it does. And it's not like some edited Kickstarter video that some guy put in some special effects and you know, edited the video to look like, oh wow, it's amazing, it's actually doing some amazing things. And I could just like, oh well, that, you know, that my amazing video that may have looked like amazing is not just an amazing video, it actually is reality, and it doesn't work. And so that's about it. And I want to thank everyone for sticking around and checking this out, especially during Christmas Eve. So happy holidays, and hopefully the next year will bring like a good round of consumer electronics that take advantage of today's lithium-ion technology, because we really need that. And I mean, if it costs the company an extra couple bucks, and I mean, these days, an extra couple bucks retail, they'll charge you an extra $20 or $100 for that extra $2 of you know, hardware cost. So hopefully next year there's a more like, you know, realization of what the capabilities of today's technology is, and that it's not all that expensive and it's not all that difficult, and we can actually have products that actually last, and you know, make it happen. And so well, one can hope. I'm not holding my breath, but who knows, maybe just a little spark of like showing that what's possible will not just, you know, that this technology is just good for cars and like really expensive like equipment, but this is what lithium ion technology is. This is what it does. It can solder, it can cut wood, it can burn wood, it can be a table saw. It can be it can heat up your jacket. You can use it to cook. I mean, and power your house. I mean, this stuff is available now, and I think it may be up to us to kind of like realize, hey, this is what's possible, and we need more products like this, and if whatever reason it's not available, we should be able to make it ourselves. And so, like I said, this is all open source. It's all available on Instructables.com. Solderdoodle Plus, all the instructions, all the code, how to program it, all the schematics, Gerber files, bill of materials, the 3D print models. I did 3D print this through a company called Shapeways.com. So they do the nylon powder 3D printing. I recommend that because these are kind of complex shapes, and a typical 3D printer can't do these fine details. So I mean, just compare. Here's a 3D print of a typical 3D printer, right? And you can see it's a little rough. It's a little difficult to install like the touch sensor into this little cavity here, just because it doesn't fit quite as nice. And then here's the nylon powder 3D print. So I do recommend that type of 3D printing. So you can make and the final design is going to have a plastic mold injection case. So it's not going to be 3D printed, but this is just a concept. And actually on my website, I have a YouTube channel called Solar Cycle 1. So my company is actually Solar Cycle. I do this actually. Might as well go into it while I'm here, I guess. What does solar have to do with soldering irons? Well, it all came down to trying to find a way to charge my phone with a solar panel. And there was a lot of batteries out there, a lot of battery packs. I've been talking about batteries out there, and it's very difficult trying to find batteries that can charge and discharge at the same time, store solar energy. Solar energy is very finicky. The voltage and the current fluctuate, and a lot of consumer electronics hate that. Even some batteries you buy out can find on the market. So these charge controllers actually, they're the Maxim 8903G charge controllers chips, and they actually handle power fluctuations very well. I mean, even on on the original Solderdoodle, even if the battery goes bad, this charge controller will actually bypass the battery and funnel power directly to the output of the charge controller. And also, it's such an intelligent charge controller. If there's excess energy, if it detects excess energy coming from the input, like whether it's USB or from a solar panel, if it detects there's excess energy, it will store that excess energy into the lithium-ion battery. That's how intelligent this charge controller is. And how do you not? I can guarantee you most batteries don't have that ability. And so I tried to build my own, and that's how this kind of finding an application. My original batteries did not really go well because the market is saturated with so much cheap batteries out there. It's hard to compete. Even if your batteries last and they're able to handle solar energy, it's still like, well, I can just go to buy a $5 thing and throw it away in a couple months. But so what? It's just $5. Well, after a couple of years, that $5 times however many times you threw it away, maybe that's the equivalent cost to like what this costs, and it still works. This would still work even after throwing away all those batteries. So it ended up being finding an application for this other than charging phones. And one day, you know, just I was plugging in USB, these funny devices that you can find online that are USB powered, like USB fans, USB vacuum, keyboard cleaners, USB whatever. And then there was actually a USB soldering iron, but you had to plug it into USB port. It wasn't battery powered. You had to plug into a USB port, and then you can solder with it. And it would break. It was cheaply made, and it could break in like a few months. Like the switch wouldn't work anymore. But I plugged it into my USB phone battery that I made. Actually, this is the original phone battery. It's called Power Core, right? Power Core. So this is completely waterproof battery that I invented a long time ago. Plugged it into this, plugged a USB soldering iron into here. So this was in my pocket, and I could solder, right? And then I didn't even think about it until like just trying to find ridiculous applications for solar energy and just show what you can do with a minimal amount of power. And then one day, a friend of mine, Kevin, actually, he's the inventor of Ardu Boy. We were just hanging out. We were talking about tiny homes. Actually, building a tiny home, that's a different subject. But he said, "Hey, I wish there was a soldering iron that was powered, like USB battery powered soldering." And I was like, "You know what? I have one using my phone charger battery that my solar phone charger battery that I invented, hooked up to a USB soldering iron." But it was like, you know, this was in my pocket. It was in my pocket, and then a cable was coming out of my pocket into a soldering iron. And I had just learned about 3D printing, and then it struck me. I was like, oh, I can instead put the battery, you know, inside a plastic case. And even though they're like, even though you know, it is the same two components, just kind of wrapped in a better package, maybe that would be a good like Kickstarter, almost like a joke, right? Like, and then people ended up really liking it, and I got funded on Kickstarter for the original Solderdoodle, and that's how it all started. It was originally a solar USB battery charger for phones. And then, so now I'm basically pushing the technology even further, and I'm still working on my solar projects on the side. And I can even show you, let's see if I have it here, a solar panel. I actually have a solar panel that I have on for sale on Amazon. And that I'm still working on those on the side. But in the meantime, this battery pack technology I want to use also for other applications. And this is just a proof of concept on, you know, using it for, you know, soldering. But if I can solder, I can power tablets. If I can solder like 10, 12 gauge wire, I can power a tablet. And I could also power like, you know, if I even increase the parallel series battery packs even further, I might be able to power a laptop. Actually on my YouTube channel, Solar Cycle 1, I do have a 3D CAD tutorial on how to do 3D CAD, and you can use that tutorial for designing, you know, products. It actually requires not special, but just like a certain type of software to go into production, because you need to have the communication tools to talk to vendors and provide all the information to vendors that you need to actually go into production. And there are tools out there, 3D CAD tools out there that will actually allow that process to go a lot faster, a lot quicker, a lot easier, and keep track of all your designs. And so yeah, Solar Cycle 1's the YouTube channel, and that tutorial, I'm actually going into the process of designing a DIY laptop which maybe, who knows, in the future of that, if it goes well, if people like it, I can also like incorporate my own battery pack designs for laptops in that particular project. And it's actually not that hard. I mean, I can use these 18500 cells. You can imagine stacking, you know, more cells back to back and just kind of dropping into a laptop case. So yeah, Solderdoodle Plus, I would say, is not just a tool. It's the idea of actually powering something that you may not have thought of with a couple lithium-ion cells that you would find in a laptop, or, you know, or even like maybe even like a drill or something. Like these batteries, the technology has gotten so good, you can power so many things with it. And there's continued support. I plan to be answering questions, supporting any customer issues, like for the entire life of the product. I don't, as a mechanical engineer, that's what I'm trained to do. I'm trained to do the whole product life cycle of products and design for that, and maintain quality, and be ethical, maintain safety, and make sure that the products last a long time, and use as much as my skills to provide that kind of level of quality and service. And so if there are issues, I actually welcome feedback. I want to know, is it going to, how long, do you have any troubles with it? And actually so far, besides some of the issues that I talked about earlier with this battery crimp, sometimes coming loose, and I do my best to do pull tests to make sure that they are strong connections. Other than some issues like that, I have had one issue where on the circuit board for the original Solderdoodle, I think there was an issue where, where did I put that? There was an issue on the circuit, like right around the charge controller. I think there was like a solder ball that came loose, and like during the manufacturing process, like shorted a couple wires. So I've seen one of those issues, you know, and I've shipped like over 500 of these things. But other than that, as far as I know, all the original Solderdoodles that were, you know, after it was first launched in 2014 and, you know, finally got everything shipped out by 2015, 2016. As far as I know, they're all still working, which is incredible, right? I mean, how many USB rechargeable products do you know that still last, you know, over, you know, it's going on the third year. So how, you know, is this just a toy? Is it disposable? I don't think so. I think I just didn't design it for that. But I think it takes a while for people to realize the quality, because the only way to know that this is not a toy is if it's still in your toolbox, right? Like, imagine how many USB rechargeable products you have out there that you've thrown away, that you don't use anymore. Like, and I'm sure they told you it was the best on the market, but like, if I told you, hey, this is the best on the market, well, you know, how are you going to know? Well, I think this kind of proves it. If this is still in your toolbox after like 2-3 years, it's probably was the best on the market. Because then how many things are in the trash by the time you kind of answered that question, right? And but all that time, it's just kind of verifying and a leap of faith, right? Like doing your best to do your own research. And so that's what I try to deliver. I try to deliver the quality, maintain the quality. I don't overpromise. I don't tell you this is going to be Bluetooth and Wi-Fi compatible and your smartphone will connect to it and like you can text your friends with it. Like, I don't try to oversell it. I try to tell you exactly what it does. And sometimes even over deliver. Like sometimes I'll find things that it can do that I'm just surprised, but I don't try to say it'll, you know, it's not gonna do silver solder. I'm not gonna say that. Oh yeah, it's gonna weld jewelry. Like I'm not gonna say that. I'm gonna say exactly what it can do. Silver solder, you're soldering silver. You need a little blowtorch because it's really takes a high temperature. But it can replace a soldering iron for sure, like a wall socket powered soldering iron. And this is just a prototype. This is just the first round of prototype circuits. And the final product is going to have a little bit different shape. Like I said, my sister, she had a little bit longer fingernails, so she had trouble using the touch interface. So we have to, this little ridge has to be moved down a little bit, make it a little smoother. And we're going to also improve this grip area. And there's also, when the vendor gave me a quote, they're also going to include a quote for possibly even rubberizing this grip area right here. And all that's going to be in the quote. Independent how much funds are raised, will kind of determine how much more improvements can we make to this. For sure, improvements to the microcontroller for making safety, even including a pro mode being the highest power level. So we can go into pro mode, and this will be like basically a setting that car audio, for example, car audio installers can use to like generate enough heat to melt solder in like 5 seconds onto like really thick wire, like speaker wire. So we can include that. And right now we're, even with that setting not enabled yet, even with the 5 second on, 1 second off duty cycle, we can still solder like 12 gauge wire, which is amazing. So we're even like, the thought is to even make that even more powerful, but also be safe and include some like overheating shut off. Like if you leave the power on pro mode too long, that it can shut off and go into like a cool down mode. And so the idea is, if you're a professional, you know when to pulse and when to let go, like a momentary switch. And so that means like if you leave it on too long, you're kind of in the pro mode too long, then it will say, okay, we gotta reset and cool down a little bit before you go back into pro mode. And we can adjust that and just fine tune. Also, the stickiness of the sensor, we want to make sure that the original Solderdoodle, there's also issues with this being a momentary switch. So you flip the on switch and then you push this little black button to power it. And there were some users who were like, well, that little, it's a spring that's inside the case. That little springiness, people felt took a little bit too much force, and after a while it might have a little like what's on my finger right now, it's like a little dent in your finger, right? Which is not good if you're doing this for a long period of time. So in Solderdoodle Plus, what we can do is we can adjust the sensitivity of not only like adjusting the power, but the sensitivity of the activation of the power. So we can actually make it sticky. So the sensor, let's say my hand's getting a little tired. Maybe the force of my finger is getting a little loose. Like maybe it relaxes a little bit. Well, we can make it so the controller is a little bit more sticky. So activating it, like once it's active, it takes a little bit more, like it will be a little less sensitive, and kind of like, well, if I relax my finger a little bit, maybe it won't like shut off right away. Maybe it'll shut off when I like completely remove my finger from the sensor. So we'll have like harder to turn on, but not easy to like, shut off. And there's a fine line, right? You want to have it shut off when you remove your finger, but not like shut off, if not having to put a lot of force on this like all the time. And so we can adjust that touch and feel. Since this is all based on touch, this interface has to be, it's going to be amplified. The user experience of the touchiness and feeliness of the user interface is going to be amplified. So we have to really go in and fine tune it. It works pretty good for a good prototype, but for final production, we're going to even make it better. There is a possibility we could find more space-saving features and maybe even reduce the overall length of this. Not by much. I think there's enough room to like get maybe at most maybe 1/8 of an inch, but you can see it's not much bigger than the original Solderdoodle. It's probably, you know, I don't know, looks, we can even measure it right now. Got my calipers, you know, I'm just going to estimate. It looks like almost like a 1/4 of an inch longer. It's not much longer. Ideally, it would be the same size, but it is double the battery, and it's obviously wider at the end. You know, a little bit fatter, a little bit taller, but I mean, that's because it's got, you know, double the batteries. Let's see, what else? I think I keep saying that's about it. I kind of keep going into tangents, and I keep saying I didn't eat lunch, which I didn't, but this is the last day of the Solderdoodle Plus campaign. And hopefully that answers a lot of questions that people might have. I haven't seen any questions in the chat. I don't think I yeah, I haven't missed anything, I don't think. So I've just been kind of rambling on, just hoping that I might have covered everything that people might have had questions on. Yeah, if there's nothing else, I think that sums up the entire Solderdoodle demo. And I guess thanks for watching, and hopefully 2019 brings more good things. And you know, I'm going to enjoy this prototype. At least I have one, and I really like it. So I know one person who has it who's thrilled. And I'm just amazed at the technology, and we really need to take advantage of this lithium-ion technology. It's kind of stagnated a little bit, and unfortunately, and you're not going to be able to, you know, run our consumer electronics without batteries, and it's kind of a shame that the quality out there is a little bit low, and really hurts the user experience, and really gives lithium-ion technology a bad name. It's the same with solar technology as well. There's a lot of bad solar projects out there that are really bad. It's a little off topic, but if you see a solar panel like stuck to a battery, like if I just put a solar panel on a battery, don't buy it. Please don't buy it, because you don't ever want to leave a battery in the sun, ever, never. Don't do it. Don't leave a battery in the sun. That's horrible. And when you see products like that out there that say, we put a solar panel on a battery, like, don't buy it. Please. It's like buying a grenade that you're just kind of lighting the fuse on. Like, so anyways, solar's been getting a bad name. Just the implementation of a lot of these products are giving technology a bad name. Like, it doesn't have to be that way. It's so, these products are so cheaply made and so like mass produced that it's it's so tempting to purchase it and try it out. Oh, maybe I can leave this battery in the sun. It's only $5. Oh, it's worth trying it out. It's like, no, don't do that. Don't do it. Yeah, and don't leave your Solderdoodle in the sun either. Please don't do that. I actually, this is literally a solar powered soldering iron. I'm getting in the weeds now, but honestly, it's crazy. It sounds kind of ridiculous, but it is. It's a solar battery charger circuit shoved into a soldering iron. So I've even asked my Solderdoodle customers, hey, what do you guys think about powering your Solderdoodles with solar panels? And they say, oh, we don't go outside. That's all right. We just solder indoors. So, but yeah, don't leave your Solderdoodle out in the sun. Don't leave your phone out in the sun either. Don't leave anything with a battery in the sun. If you have a solar powered anything, make sure there's a long cable attached to it so your solar panel is in the sun and whatever product you're charging is in the shade. Keep batteries in the shade, put solar in the sun, but keep batteries in the shade. Just remember that, and life's good. And yeah, and enjoy the new year. And thanks for everyone who's stuck with this live stream so far. And yeah, and hopefully other people get a chance to experience Solderdoodle Plus. Right now, it seems like very few people have the ability or to do it. Hopefully this live stream like kind of expands that kind of virtual experience, I guess. But yeah, I'd like to see more people enjoy it, and also whatever happens, feel free to, if you're, I'm in Portland, Oregon. I don't know where everyone else is, but heck, if you have any questions just about solar, about Solderdoodle, about anything, about power packs, feel free to just contact me, message me, or whatever. I'm cool with that. I'm cool with sharing information. It's not a big deal to me. Like I said, it's not just a tool. Solderdoodle Plus is not just a tool. It's also like I don't mind supporting products for the life of the product and also beyond the life of the product, and just sharing information in general. That helps everybody. That helps the market stay at a high quality. If we're all educated on how things work, then we're less easily tricked by these, consumer electronic sales and marketing tricks. Like, oh, put a solar panel on a battery and leave the whole thing in the sun. Like, that's a genius sales and marketing trick. It works. But if we're educated, it doesn't work as easily. So again, thanks for watching. Have happy holidays, and hopefully good things to come in 2019.